Hey everyone, the given question is from the topic of gravitation, paper 1 2022. So the question says that there are two spherical stars A and B and they have densities rho and rho b respectively. A and B, they have the same radius and then masses m and nb are related by this relation. Due to an interaction process, star loses some of its mass so that its radius is halved while its spherical shape is retained and its density remains rho. The entire mass lost by A is deposited as a thick spherical shell on B with the density of the shell being rho A. And this is important because we'll use this to calculate the new radius. If VA and VB are the escape velocities from A and B after the interaction process, we need to calculate the ratio of VB by VA that is given in some form. We need to calculate n, the value of n. Okay, so first let's calculate what the escape velocity formula is. Let's derive that by conservation of energy. We can say that delta U is equals to delta K. Change in potential energy is equals to change in kinetic energy. Initial is 0 because it will go to infinity, it's escaping out, minus G capital M small m by R. This is the formula for potential energy, that is equal to half m v square. Okay, this gets cancelled, so v comes out to be root 2 gm by r. Okay, right, so we know that this velocity depends on mass and radius and it has changed. So we need to calculate what the new mass and the new radius would be. The new radius is given, which will be equal to r by 2. New mass, you can easily calculate, it's ma by 8 because mass is directly proportional to r cube given density is constant. So that's how we get this. Now coming to rb dash. So calculating rb dash is a little tricky. First let's write mb dash. This would be equal to mb plus the mass removed, that is 7 ma by 8, and mb is equal to twice of ma, so this would be equal to 23 ma by 8. Okay, now this mass is added, right? This mass is the extra mass added. This would be equal to density of A into the volume that is added, the volume in the sense this volume, and this volume is equal to uh, 4 by 3 pi rb dash cube minus r cube, and rho A is ma upon 4 by 3 pi r cube. Okay. A few terms get cancelled out. We get 7 upon 8 r cube plus r cube is equals to rb dash cube. This would implies that rb dash is equals to 15 under 1 by 3 to the power 1 by 3 by 2. Okay, so we have ma dash, ra dash, mb dash and rb dash. Now we should calculate the escape velocity, the ratio vb upon va, that would be equal to root 2 g mb dash, that is 28 ma by 8, 23 ma by 8 upon r, that is 15 per 1 by 3 r by 2, this into the escape velocity of this divided by the escape velocity of Va, and that would be equal to r by 2 upon 2g ma by 8. So ma by 8 gets cancelled, r by 2 gets cancelled, 2g gets cancelled, and we get this to be equal to 23.15 q power 1 by 3, which is equal to 2.3 into 10 upon 15 to the power 1 by 3, and this implies that n is equals to 2.3. So this is the answer. Thank you.